Now, to all the students in this class, listen before you read. I would like to say something about the quantum mechanics, the start of quantum mechanics actually, how it started, that I would like to say here. Now, all you know that according to Niels Bohr, the atomic theory suggests that the electron is rotating in a circular orbit and the heavier particles, photons, that is inside the atoms, and the electron is rotating in a circular orbit as because of this very fact. Whenever it got energy from outside, maybe electrical energy or thermal energy, it will go from the lower energy to level to higher energy level. But the point is that when an electron is rotating in a particular orbit, it means we are basically locating the electron in an orbit. It means we are particularly enabling the position of the electron in a particular place. What does it mean actually? See, the electron is in this place. So we are locating this electron here. We have the power to understand this electron is here. Here the electron, here may be the electron. So otherwise we cannot say that the electron is rotating in a circular orbit. How can you say? Electron is rotating in a circular orbit. It is only can be said, and we can say only this, only when we are able to locate the electron. We are able to locate the position of the electron. But one principle, Heisenberg's uncertainty principles. Heisenberg's uncertainty principle. Uncertainty principle. When came into picture, there it has been written delta x dot delta px greater than h cot or h cot by 2 for monoatomic structures. So delta x is the change in displacement, change in the position, and delta px is the change in the momentum. P stands for momentum in the x-axis, in x direction. So delta x into delta px is greater than equal. So h cot is the Planck constant. H cot is equal to h by 2 pi. H is the Planck constant. 6.62 10 to the minus 34 second. So delta x dot delta px greater than equals to h cot by 2. So what does it mean actually? So here the error in x, delta px is error in delta px, momentum, error in momentum. So error in positions and error in calculating the momentum is greater than equals to h cot by 2. It means you cannot locate the positions and momentum together at a time. If you can locate the position, then there must be an error in locating in actually calculating or measuring the momentum. And if you can measure the momentum in actual basis, in a true value, then definitely there is an error in locating the position. So both the positions and momentum you cannot measure in an accurate way simultaneously, in all together. And there must be an error, and that error is greater than equals to h cot by 2. So why is it so? According to Heisenberg, to locate an electron, suppose you have with you some measuring scale. Suppose I want to locate this, but I want to measure the length of this, suppose. Then we need to have a scale, and that scale must be smaller than this. Otherwise, suppose 1 centimeter, so it is up to 3 centimeter, we can say. If you take a scale of 1 centimeter, suppose if you have a scale in which a 1 centimeter gradation is there, then you can measure it as 3 centimeters. But if you have a scale of 1 meter, suppose the minimum value of that scale, gradations, is 1 meter, then how can you measure this? You cannot measure it. So to measure the length, you need to have a scale lesser than that of this. So to measure the positions of an electron, to measure the momentum of the electron, you must have a lower momentum of that. But you have with this electron is very fundamental. Electron is very, very smaller particle. So if you strike this electron by an electron, suppose, to measure the actual momentum, suppose how can you measure, how can you calculate the momentum? You just have a rays, electron, a rays is coming here, it is striking here, and after reflections it will come here. Then you can locate the positions of the electron. But the rays here, which you are sending, so the wave particle, from wave particle duality, so that is you can say that a particle is when attacking here, a particle is when impinging, a particle is striking. Both this electron and this particle is almost equal masses. So it means when it will strike, it will go on and it will displace from these positions. And if it displaces from this position, so both are of say equal masses. If the masses are not equal, if it is a heavy mass, suppose a ball is there of suppose 1 gram and it is of 9 electrons, mass is 9 into 10 to the minus 28, 10 to the minus 31 kg. And if it is going and if it is striking, then this striking has no impact to the position of the particle which has a very larger masses. But here, the masses of this electron is also very small. And as the mass of electron is very small, when it will strike, it will displace the electrons. So it means you cannot locate the positions of electron very precisely. And that is the error. And that is given by Heisenberg, this uncertainty principle. And if you locate the positions, I think, if you locate the positions very absolutely, then you cannot locate the momentum, how it is moving. So it means, if we cannot locate the position, then how can you say the electron is rotating in a circular orbit or electron is rotating in an elliptical orbit? How can you say? You cannot locate the position. Then how can you say like this? So the whole system of Bohr's theory, Niels Bohr theory, Rutherford theory, and all this Sommerfeld theory, everything goes in vain. Everything becomes fruitless when the Heisenberg uncertainty principle comes. Then the de Broglie's relations comes into play. What de Broglie said? That lambda is h by p. The beauty of these relations of de Broglie hypothesis, that here in the left hand side you see the wavelength lambda, and the right hand side you see p, the momentum. Momentum comes from the particle, and lambda comes from the wavelength. So this is wave particle duality. The wave particle duality has been given by an equations. Lambda is equal to h by p by de Broglie. So any wave when it is going, any rays when it is coming, you can say that a particle. So a particle is coming and striking here to measure the momentum. How? But if you measure the momentum accurately, then you cannot locate the positions accurately. So there is an error as per Heisenberg, uncertainty principle. So this is lambda is equal to h by p when come. Then the concept of this particle, the electron which is moving, is transformed into a wave function by this theory. So if we consider it as a wave, and if we consider it as a wave, that we should not bother about the positions of the electrons where it is rotating in a circular orbit like this. We simply say there is a wave function. The wave function is there, and wave functions in a particle. The wave function is representing a particle. The wave function is contained in a box, and in a box in such a way that when it has been normalized, it gives a value of unity. The path of quantum mechanics thus this is a part of the quantum mechanics comes, and by this way a new mechanics developed from the classical mechanics, a new changes to the quantum mechanics actually started with the concept of this wave function. And if we consider these wave functions instead of the particle concept, then and the wave functions, with these wave functions we have a new equations that is given by Schrödinger, the Schrödinger wave equations. And Schrödinger wave equations is such that with these Schrödinger wave equations you again can have the idea of the positions of the electron, the position what we have got the idea by Niels Bohr theory and others. Here also we can grasp the idea of this position of wave functions. So the path of quantum mechanics comes. So a new mechanics developed, that is quantum mechanics. I think people, all the students, you have enjoyed my classes. And if you enjoyed these classes, please subscribe my channel, listen before you read, and it will be more energetic also for me to take more classes for you and to give more fundamentals for you. Thank you all.